Here we can see the Cannizzaro reaction. So here in this reaction, the aldehyde with no alpha hydrogen atom will respond in this reaction. So the alpha hydrogen atom absence is the main criteria of this reaction. So here you can see that, let's say an example of an aldehyde with no alpha hydrogen atom, let's say RC double bonded OH is an example of aldehyde. In this case, a nucleophile such as a hydroxide ion is used to attack the carbonyl carbon atom. Let's say OH minus is the hydroxide ion. This will attack the carbonyl carbon atom, which is electrophilic in nature, and after that it will generate a O negative or oxide ion. Thus it will generate O minus, and the hydrogen atom is like this, and the other OH atom here will be attached in this group. Okay, now the another molecule of OH minus, that is hydroxide ion, will abstract this hydrogen, and ultimately it will generate a dianion of oxygen minus, that is O minus over here in the above and below, and hydrogen will be here in this case. So this is a dianion will be formed, and after that in the next step the dianion will be acting like a reagent. So here we minus O minus here, and the H here will get eliminated from this compound, and so subsequently the O minus will form a double bond with this compound, and another carbonyl carbon atom will attached with this carbon atom, and here the O minus will be generated, and thus the first one will be converted to an carbonyl carbon atom. So this is O minus and carboxylic acid anion, and the another one will be attached with hydrogen atom, and it will form CO minus, and thus alcohol will be generated. Basically primary alcohol will be generated in this case, and it is thus the both compound will be converted to its protonated version. So proton will be attached with this from solvent, and this is converted to the carboxylic acid, that is OH, and the alcohol is converted to primary alcohol, that is RCH2, and OH is generated over here. So this is basically the mechanistic steps, and you must have to understand this mechanism to understand the actual reaction over here. So now I will go to specific examples. So like in case of a compound where only two aldehyde group is attached to a specific one molecule, like CHO here present in this molecule, also another CHO group is present. So in the aldol Cannizzaro reaction, here one CHO group is converted to carboxylic acid and another CHO group is converted to alcohol functional group. If here alkali is used, so the first step is the use of alkali, and the second step is the use of water, that is basically H plus and water. Hydrolysis step is will help to convert it to the carboxylic acid and the alcohol, basically primary alcohol. So if in this compound the first one is converted to carboxylic acid, so this A portion is converted to carboxylic acid, let's say, and the B portion is converted to a primary alcohol, then we can write over here like the benzene ring will be intact, and the upper A will be converted to a carboxylic acid, so COOH, and the lower part, that is B part, aldehyde, will be converted to primary alcohol, basically CH2OH. So this is the product of this compound. Because of because it is happening in a single molecule, so it can be called that this reaction is intramolecular Cannizzaro reaction. This is intramolecular Cannizzaro reaction. Okay, I think it is clear now. Now I will give examples of some crossed Cannizzaro reaction. Because the here you can see that benzaldehyde is there and the other is formaldehyde is used. In case of this reaction, if 33% of NaOH, that is base, is used, strong base is used, and in second case the hydrolysis is done, then this CHO group is converted to a primary alcohol, and that is the corresponding benzyl alcohol is formed. So CH2H is formed over here, and the other aldehyde, that is formaldehyde, is converted to its carboxylic acid analog, that is HCOOH, that is formic acid, is formed over here. So in this reaction, because of the different type of aldehyde present and the reaction is happening. Question, here is a question of Cannizzaro reaction. So it is said in the question that which of the following undergoes Cannizzaro reaction. Though the basic criteria of Cannizzaro reaction is having no alpha hydrogen atom. So if in a compound there is no alpha hydrogen atom, then it undergoes obviously Cannizzaro reaction. So in this first case, if CHO is the basic group, then the corresponding atom is the alpha atom, so it has one alpha hydrogen atom, so alpha hydrogen atom is one, so it will basically undergo Cannizzaro reaction. No, it will not undergo Cannizzaro reaction, but it is actually an exception that will undergo Cannizzaro reaction. It will undergo Cannizzaro as well as and aldol, both reaction. Okay, but in general, alpha hydrogen, the absence of alpha hydrogen atom signifies that it will undergo Cannizzaro reaction, but it is exception. So having alpha hydrogen atom, it will also undergo the Cannizzaro reaction. But in this case, you can see that in previous examples also, that in this example this is written as like this, and so in this example no alpha hydrogen is there because only one carbon atom is there, so alpha hydrogen is absent, so it will undergo Cannizzaro reaction. In the later example, it has alpha hydrogen atom, no alpha hydrogen atom, so it will also undergo Cannizzaro reaction. And in the next example, here because of the alpha carbon, it has alpha hydrogen atom and number of alpha hydrogen atom is 3, so it will not undergo Cannizzaro reaction. Okay, this question you can see that in a Cannizzaro reaction, the intermediate that will be the best hydride donor is. So in this example, here the option A, B, C, D is over here, so this is the option C. In this reaction, the hydride donation will be explained by the mechanism of the dianion a dianion intermediate of Cannizzaro reaction. Let's say in an aldehyde functional group, the dianion is formed over here like this, and the hydride is donated. So the R group, if the R group is electron donating in nature, then the hydride donation will be lower, and if the R group is electron withdrawing in nature, so the donation will be more. So hydride donation is proportional to the electron donating group. So here you can see that in the option there is no electron withdrawing or donating. In option B there is also no electron withdrawing or donating, but in case of C, here the plus R effect or electron donating group of methoxy is present, and in option D the minus R effect or electron withdrawing group is present. So it will facilitate more to donate the hydride. So the best intermediate for the Cannizzaro reaction is option D, because if simply you can remember that if electron withdrawing group is attached over here, then it will facilitate the hydride donation, and if electron withdrawing group is there, then it will facilitate, and electron donating group or that EDZ is there, then it will hinder the hydride donation. This is if you explain this, this is basically because if electron withdrawing is group is there, then electron density will be withdrawn as well, and thus the carbon hydrogen bond here, the carbon hydrogen bond will be merely weak, and it will break down afterward, and the hydrogen or hydride donation will be easy more. So electron withdrawing group result in the flexible donation of the hydride ion from the compound. So the answer is option D. So here in this reaction, the questions says that the metachlorobenzaldehyde is treated with 50% KOH. So this is also the example of Cannizzaro reaction. In this reaction, the compound is bit different, but you can predict that from this the Cannizzaro will happen, because in this compound at this side no alpha hydrogen atom will be there, so it will respond in Cannizzaro reaction, and thus the two molecule of this benzaldehyde, that is metachlorobenzaldehyde, will converted to one will be converted to the carboxylic acid analog, that is the one benzaldehyde will be converted to COOH and metachloro format, and the other will be converted to the primary alcohol format, and the meta position will be occupied by the chlorine atom, and only the the main position will be attached to the alcoholic format. So this is basically the simple reaction, and this is A and the other one is B, but it is the starting molecule that can confuse it. So the first one will be converted to the carboxylic acid analog, and the other one will be other molecule of benzaldehyde will be converted to the alcohol format. That is simply it will be the answer. Sometimes it is given that not by giving this COH, they may give you that COO minus and hydrogen is not present there. So that will be fair enough to predict that this is also the Cannizzaro reactions product, and thus this can be solved. So in this reaction you can see that a single compound is containing 4 CHO group above 2 CHO group and below 2 CHO group, and it is treated with sodium hydroxide, and 100 degree Celsius temperature is applied, and in the second step hydrolysis is applied. So what is the major product? It is came in IITJ 2003. So in this case you can see this is clearly the Cannizzaro reaction. So in Cannizzaro reaction, if 2 CHO group are there in a single compound, then one CHO compound group is converted to CO2H, and the other is converted to COOH. So this is converted to CH2OH, that is primary alcohol functional group, and the other CHO group is converted to the carboxylic acid, that is COOH. So here if you consider this compound, so maybe it is imagined that the first CHO group is converted to CH2OH, and the second one is converted to carboxylic acid. But in the first example you can see that all the CH2 CHO that is aldehyde group is converted to the COH group, that is carboxylic acid group. So it is not possible that all will be converted to the COH group, so it is not the answer. Now I will talk later about the option B, but let's move to the option C. In option C, it is the OH group which is attached directly to the benzene group. So it is not possible, because there is a CHO group and one carbon atom is absent here in this option. So option C will not be the answer. In option D, here you can see that all the groups are has been converted to CH2 group, so alcohol group. But in the Cannizzaro reaction, it is observed that one aldehyde group is converted to the carboxylic acid group, and the other aldehyde group is converted to the alcohol group. So if we imagine the B option, so it is actually the converted thing. So the intermediate should be like, if you write down the compound of the starting molecule. So I think this is first aldehyde will be converted to the carboxylic acid group, and the other one will converted to CH2OH group. Okay, so now if it is converted to the CH2OH group and the other one is converted to CH2OH group, and this is converted to C double bonded OH group, that is carboxylic acid group, then it is possible, it might be possible to attack this carbon atom to this carboxylic group acid, and OH will be eliminated, and like this OH group can attack this carbonyl group, and further this OH group can be eliminated. So in that case, here one CH2 group is absent, because here there should be one CH2 group and it is bonded to this O group again, and later in the rear portion it also have to be a CH2 group. So the thing will be clear then, of course. So it is not there, and here in the above case it is also not be there. So I don't know so what is the actual answer, but according to me the answer should be this option B. And if the option D will be another, like this carbon atom is COOH group, and the alternate carbon atom, this carbon atom is COOH group, then it could be possible that it is the answer. But according to the options, the answer is B, option B might be possible. Okay,